Hello everyone. Welcome again to the live discussion. Today our topic is Wi-Fi versus LoRa, which to choose and what are the key differences. So I welcome Mr. Ashwini Kumar Sinha and Suresh Dwivedi ji to discuss their insights on this topic. My first question is, what is the basic difference between LoRa and Wi-Fi?
Yeah, so the basic difference between the LoRaWAN and the Wi-Fi is the range. The Wi-Fi is especially designed. There are two basic differences. If we go for the difference, the range and the speed. So if the Wi-Fi use very high speed, give you very high speed of transmission of data and around certain Mbps to the certain Gbps as well. But while LoRa can only give you around some certain kbps of data, like 0.3 kbps to the 50 kbps of maximum data rates. So this is the data transmission rate is little bit low in the LoRa, while Wi-Fi exceeds in that. And second thing is the range. The as you can as you can sense from the name, long range wide area network, LoRaWAN. So it's for the wider area. It will give you the long range in that case. But in the Wi-Fi, it give you the very short range around 100 meters, not more than that. So these are the two basic difference between the both technology. But both technology use the RF technology. Both are the RF. They both use the radio frequency. So this is one of the similarity. But on the different side, these are the two difference, basic difference between the both technology. Sorry, you are mute, I think.
Sorry. Okay, so how does the environment impact the range of Wi-Fi and LoRa?
Yeah, so if you consider the Wi-Fi, then it's also using the RF technology, and LoRa also use the RF technology. But in case of the Wi-Fi, if you see the urban area, in the urban environment, in the indoor environment, in urban area, it is really highly populated, and lots of buildings and a lots of infrastructure are there. A lots of Wi-Fi are already there inside around you. A lots of BLE technologies, a lot of other cell phone towers are already there. So in the urban area, it is a little bit hard for the Wi-Fi to perform better and give you the higher range. In indoor, it works pretty well, but it's outdoor. It's exceed little bit, but not that much, and it didn't perform that much in the outdoor environment. And in the indoor, it can the Wi-Fi can't penetrate the wall that much, and Wi-Fi signal can't penetrate the wall that much. So after every wall, there is a drag in the signal strength in case of the Wi-Fi. But if you go for the LoRa thing, then it in the urban area, it can reach the larger space as well, and they have better penetration level in the through the obstacle like the wall or some glasses. They can penetrate better, so they can give you the wider range and give you good signal strength, even if there are lots of construction out there. There are lots of obstacle out there in the and in the rural area. It's a great, it's just give you the good signal strength, because there are very less infrastructure out there, very less amount of building, there are very less amount of wall out there, and it can even penetrate those walls, and it can that signal can even penetrate the wall and transfer it through the wall. So for the Wi-Fi case, it's not pretty friendly for the urban, where a lots of obstacle, a lots of infrastructure, a lot of wall out there. It is good for the rural as well, but Wi-Fi suffers in both cases. In both cases, rural area and urban area, both cases. But it worked well in the indoor environment, not in outdoor environment. While if you use the LoRa technology, that it can work well in the outdoor and indoor environment both.
Okay. So how do the data rates of Wi-Fi and LoRa compare? And how do you decide which is more suitable?
Regarding the comparison of Wi-Fi and the LoRa data rates, there are various differences. In case of Wi-Fi, data rates high data rates ranging from 11 megabyte per second to over 1 GPS. And where these are used, normally it is Wi-Fi is suitable for the applications requiring high speed internal access, large data transfer, video streaming, and the real-time communication. While in case of LoRa means long range, so it has a certain limits. LoRa offers significantly lower database rates, typically ranging from 0.3 kbps to 50 kbps. So where LoRa are used, LoRa designed for the low power long range communication. LoRa is ideal for IoT applications such as sensor network where a small amount of the data are transmitted intermittently over the long distance. Now the question arises, oh, how should we choose between the Wi-Fi and the LoRa? In case of Wi-Fi, we choose if you need high data throughout low latency and stable connections within a limited range. For example, within a home or the office. So another application is best for the serious requiring condition or high volume data transfer like video calls, file sharing, and the internet browsing. So for these purposes, you can use the Wi-Fi. While in case of the LoRa, we opt for the LoRa when the applications involve long range communication up to the 10 to 15 kilometers in the rural areas. Low power consumption and the low data transmission like sending sensor data, etc. These LoRa's are the ideal for the scenario where the devices need to operate on a batteries for the years and are located in the remote or difficult to reach areas. In brief, we may say that the Wi-Fi is better for the high speed, short range communication, while LoRa is low power, long range application where only a small amount of data are exchanged. That's all.
So how does the power efficiency of Wi-Fi compare to LoRa, especially in battery powered applications?
Yeah, so for the battery power application, of course, LoRa is a better technology and better way to save the battery for the if you want to give the transmission at or if you want to give the device transmission range high and give the device a better battery life and better performance, then of course the LoRa is. So actually the Wi-Fi is designed so that it can give you the very fast speed. But when its speed is very fast, it uses a larger bandwidth, and so that it also consumes more power. So its Wi-Fi gives you the more fast speed, higher bandwidth, but very power hungry. But in the case of Wi-Fi, it also gives you the sleep modes function in various chips, so that you can make the Wi-Fi sleep, and whenever you need the transmission, then you can make it wake it up and transmit. So if you want higher transmission rates and it's very real time data uploading and very real time of sensor data updates, or then Wi-Fi is a good choice in such case. So Wi-Fi gives you the it's really very power hungry, while if you see the LoRaWell technology, then it is very less power consumer. It takes very less amount of power and it gives you the wider range as well. But in this technology, the speed is very slow. So in case of the LoRa technology, it give you the 140 millijoule to 667 millijoule of the power range. But in case of the Wi-Fi, if you see the power consumption of the Wi-Fi, then it takes you the 2 to 20 watt electricity. So if you need a lesser amount of data to be transmitted at lesser amount of time, and you need a good battery backup and more efficient power efficient device, then the LoRa technology is good, because it's only used around 140 millijoule to the 667 millijoule. And this both of the technology also give you the function for the sleep. Like you can keep that main transmission thing sleep. Whenever you want to transmit, then it will wake up and connect to the device and transmit that thing. So both devices give you the sleep function, but in case of the Wi-Fi, it's consumed 2 to 20 watts of electricity, while LoRa use 140 millijoule.
So, what are the network capacity limitations of Wi-Fi and LoRa, and which technology scales better? Suresh sir, you are on mute. Uh, Ashwini ji, do you want to answer this question?
So can you repeat the question?
Yeah. What are the network capacity limitations of Wi-Fi and LoRa, and which technology scales better?
Yeah, so in case of the Wi-Fi, you will get advanced encryption of standard AES technology. So actually, it gives you more security, and it gives you in the case of the Wi-Fi, it gives you the end-to-end encryption thing, so that whatever the data you want to transmit, it can encrypt that data. And you can use various cryptic chip along with that, the Wi-Fi technology, and you can encrypt the data accordingly. And so there is the end-to-end encryption in case of the Wi-Fi. It also provide you the advanced encryption standard AES, and that is what we call WPA2, that Wi-Fi protocol access, or WPA3 Wi-Fi protocol access 3, or other various advanced encryption system and end-to-end encryption system. It also give you the two-factor authentication system, or the authentication system protocol, that using which you can user can authenticate to connect with the device, and then it can only transfer the data to you. But in case of the LoRa, its security is little bit concerning thing. But this technology as well gives you the little bit of security as well. Like it gives you the AES 120 encryption system, and it also gives the end-to-end security system. But in case of the Wi-Fi, the security is, this is my opinion, that what I experienced, that security is little bit higher, and the data transmission with the Wi-Fi is more secure. This is what I have experienced, and this is what my thought is. And you can also share your thought, what you think. But I'm just sharing my thought, how it's secure is the security comparison between the LoRa. So I trust Wi-Fi more, because it give you the lots of encryption system. You can also add the encryption chip certification, all those things, and you can add the two-factor authentication system, and then you add another layer of encryption system on that. So first you need a password to connect with that Wi-Fi network, and after connecting that Wi-Fi network, you can even encrypt your message as well. But in case of LoRa, it is not that thing.
That was a very nice explanation. So, how complex is the deployment and maintenance of a Wi-Fi network versus a LoRa network?
Yeah. So if you see the complexities on the both thing, then for the Wi-Fi network, as you can see, the power is very problem it is very power hungry. So if you want to deploy a Wi-Fi based system, Wi-Fi based device, then you have to think about the power, because the battery get drained so quickly. So you have the access. You need the access to the device, and there should be the power available nearby, so either it can get charged, or you can get, it can directly get power from the power line in the Wi-Fi based technology. And if you use the LoRa based technology, then it is very power efficient, as we have already discussed earlier. So if you deploy this technology where there is very less amount of power available there, and or you can say that in village or countryside area, so you can charge the battery in the day using the solar a small solar panel, and then you can that device can run for the week or 2 week whenever, and then you get charge again. So in such case of scenario, the deployment of LoRa is very good in for the area where there is less power connectivity, and there you need to transmit the data, and where you need the larger bandwidth and larger area of of the coverage area. But in case of the Wi-Fi, it's power, as it power hungry, then you have to. It is good for the urban area, like in metropolitan city, where you can deploy the different sensor nodes for the pollution monitoring and all others, where the power is not that big problem. You can easily get the power from the light poles or from the bridges or in the office and all the other area.
So talking about the infrastructure, what infrastructure is needed for each, and how does this affect the deployment cost and time?
In fact, in case of the Wi-Fi, access point is very important. In Wi-Fi network, require access point to broadcast the signal and the connected devices. The number of APs needed depends on the coverage area and the density of the device. In large areas, multiple APs are required for the seamless coverage. And another is the wired backbone. Each AP usually connects to a wired network via the Ethernet cable, which requires cabling throughout the deployment area. Network controls. For the network control, for large deployments, a centralized controller may be needed to manage multiple APs, ensuring consistent performance and the security access the network. Another is the power supply. APs needed, access points needed a reliable power source either through direct power connections or the power Ethernet PoE. And deployment cost and the time. In case of the Wi-Fi, the cost of the deployment Wi-Fi can be high due to need of the multiple APs, wired installation, and potentially sophisticated network management system. And also take time because the deployment can take considerable time, especially in the large or the complex environment, such as it involves planning, cabling, and the installation of the multiple APs. But infrastructure in case of the LoRa. So in first its gateway, LoRa network requires gateways to receive the data from the LoRa-enabled devices and forward it to central server or the cloud. Fewer gateways are needed compared to Wi-Fi APs because each gateway covers a larger area up to the 10 to 15 kilometers in the rural areas. Network server is also very important. A central server, either on premises or cloud-based, is required to manage the network, process data, and handle the communication between the devices. Another is the minimal infrastructure. In case of the LoRa, devices are typically battery powered and operate by the years without direct power supply or complex wiring, reducing the need of the extensive infrastructure. So where LoRa's are deployment at cost and time, the cost of the deploying the LoRa network is generally lower than the Wi-Fi, especially over large area as the fewer gateway are needed and there is no requirement for the extensive wiring or the power infrastructure. And in case regarding the time, deployment is faster since fewer physical components are involved and the LoRa devices can be placed and activated with the minimal setup. So in brief, you may say it require in case of Wi-Fi, it requires more infrastructure, APs cabling, power, leading to the higher deployment cost and the longer setup time. Environment needing high speed, high capacity, and the connectivity. While in case of the LoRa, it needs minimum infrastructure, resulting in lower deployment cost and the faster, especially over a large areas, ideal for the IoT application with the many low power long range devices. To choose between Wi-Fi and the LoRa will depend on the specific requirement of the deployment, including the area coverage, data rate, needs to a budget, depends on your pocket. That's all.
So, is there any maintenance cost also associated with Wi-Fi and LoRa? And if you compare both, how can you compare both the cost?
Okay, so maintaining the Wi-Fi network is little bit not in the Wi-Fi network thing. You need cabling for the routers and all those things. The power, the maintaining the power system for the Wi-Fi routers. So in Wi-Fi it is little bit less expensive, but in case of the LoRa, it is it's very very point to point comparison. So in case of LoRa, if you see the gateway, then the LoRa gateway are really expensive, and you need to you need to continuously monitor the gateway thing, so that and check the performance of each nodes that are connected to the gateway, that they are working fine or not. But in case of the Wi-Fi, you need to look on the power consumption side, you need to look on the wiring side for the router, so that they can get the continuous connectivity. So in the Wi-Fi, it have the router. So routers are either getting internet using the cellular network like Geo5 or something like you have already seen, or either using the PoE, power over internet, the Ethernet cable, that can be get power using the same Ethernet cable, or if it can be, router can be powered externally, and Ethernet will provide the internet service, and that is being transmitted using the router, and or either using the fiber optics. It can get power, router get power from the your board, and the fiber optics will provide you the provide you the internet connectivity. So in all those cases, you have to look the wiring, you have to cross check the wiring every time, so that if there is a damage in the power optics, then the whole communication get disturbed. If there is a damage in the Ethernet cable, then the whole communication get disturbed. If the damage with the the cellular network towers, then whole communication get disturbed, because the router is not able to provide the internet connectivity in the Wi-Fi in the Wi-Fi system. And second thing is the power. The device need to be that router router is very power hungry because it's transmitting the signal around itself continuously. And I've already told you that the Wi-Fi consumes a lots of power around 1 watt to the 2 watts. So it need continuous power supply either from the electrical socket or using the UPS and the electrical socket or using the battery and the solar panel. So there is in the Wi-Fi you have to the maintenance service is maintenance system is little bit costly if you go for the router thing. But for the rest of the device, the rest of the node that is connected to the main router, the maintenance cost is little bit less. But for the LoRa thing, both things are very not that much expensive. It is very cheap. So if you compare for the power, the maintenance service and the maintenance cost, the Wi-Fi is little bit more headache for your maintenance and more costly as well, because you have to maintain the one of the system that is providing the internet connectivity. Either it's the fiber optic cable, or it's the Ethernet port, or it's the cellular network, and then the power line as well.
Okay, so how do the frequency bands used by Wi-Fi and LoRa comply with local regulations?
In case of the frequency band and the regulatory compliances, first we consider the Wi-Fi. So Wi-Fi, in the case of Wi-Fi, frequency band is very important. Wi-Fi primarily operates in the 2.4 gigahertz and the 5 gigahertz. With the newer standard also using the 6 gigahertz band Wi-Fi. And in case of regulatory compliances, 2.4 gigahertz band, this is a globally unlicensed band, meaning it can used without a specific license in the most of the countries. However, local regulators may impose limits on power devices, that is the output, and the channel availability to avoid the interference with the other devices like Bluetooth, microwave ovens, etc. Another is regulatory compliance, 5 gigahertz band, also largely unlicensed, but there are more restrictions compared to the 2.4 gigahertz. In some regions, certain channels are reserved for the radar system. For example, dynamic frequency selection or DFS channels, etc. And devices must be capable of avoiding interference with the system. Another is the 6 gigahertz band. The availability of this band of the Wi-Fi varies by the country, and it is more tightly regulated to manage interference with the existing services, fixed satellite systems. Now, what is the impact of these deployments? Actually, global consideration, Wi-Fi deployment generally requires careful planning to comply with the local regulatories, particularly concerning power limits and the channel uses. In some countries, certain band or channel may not be available, which could affect the network performance or require adjustment to the design. Now comes under LoRa. Its frequency band is limited. LoRa typically operates in sub-gigahertz ISM. ISM stands for the scientific and the medical performance bands, with the exact frequency depending on the regions. For example, in the Europe 868 megahertz is used. North America, it is 915 megahertz. In the Asia, varies by often around 433 megahertz to 920 megahertz. What are the regulatory compliances of the LoRa? So in this case, these IMS means industrial, scientific, and the medical bands are unlicensed, but their use is governed by the local regulatories, which may impose restrictions on the transmission power, duty cycle, how much a device can occupy the channel, and the bandwidth. Another is it complies with the regional regulatories too. For example, ETSI in Europe, FCC in the US is essential to avoid the interference with the services and ensures the legal operation of the LoRa devices. What are the impact on the deployment of the LoRa? So these are the regional variations. LoRa network must be tailored to the specific frequency band and of the deployment region. This might require configuring devices and the gateways to operate within the legal limits. And in some cases, adjusting the network design to account for the restriction on the duty cycle or the power output. So in brief, we may conclude that generally, in case of the Wi-Fi, generally operates in a globally recognized unlicensed band, but in the 6 gigahertz band. It's crucial to avoid the interference and ensure the legal operation. While in case of the LoRa, it operates in the
Okay, I think there is
the
some
region is specified ISM batches
connectivity issue with today's call.
issues. Development must be carefully to abide. That's all.
Okay, so how do the
Hello?
latency? Yes, yes. So how do the latency characteristics of Wi-Fi and LoRa differ, and which is more suitable for real-time applications?
Yeah, so if you look at the Wi-Fi, then I have already told you that the Wi-Fi are really fast, and for the real-time application where you need a real time of data transmission, and you have the large number of data like you have data of lots of sensor, you have the data of whole city sensors of environment sensor, or if you have data of a lots of patient in the hospital and want to transmit at once, then for the real-time application and the large number of data, the Wi-Fi is the best solution for such cases, because in case of the Wi-Fi, it gives you the larger bandwidth, and there is even latest even the another bandwidth, that is the 5 gigahertz Wi-Fi, the 5G Wi-Fi. So earlier we are using the 2.5 gigahertz Wi-Fi. Now we have the 5 gigahertz Wi-Fi. So the bandwidth is even increased, and the speed also increased as well. So for the real time application and very fast processing and very fast transfer of data, Wi-Fi is the best choice. Because and in case of the Wi-Fi, you will face only the 1 to 20 microsecond of latency. So it's very small. It's very small latency in case of the Wi-Fi. Like all of you, most of you are experiencing the speed of the Wi-Fi by watching the real-time 4K video on the Wi-Fi transmitted to your smart TV, right? These days. So Wi-Fi is really fast, and for the real-time application and the large number of data, the Wi-Fi is the best choice. While the LoRa technology, it gives you the latency around 1 to 10 seconds. So in the case of Wi-Fi, it's the microsecond, and in the case of LoRaWAN, it's the second. Once the microsecond and once the second. The large difference, it's Wi-Fi give you only 1 to 10 microsecond, while LoRa give you the latency of 1 to 10 seconds. So whatever the data you are transmitting, the data packets are transmitting from the LoRaWAN. So the device have transmitted the gateway, the device have transmitted the data packets, and the receiver might receive the data packets after the 10 seconds. There is a large gap between the transmission time and the and the receiving time. And in case of the Wi-Fi, there is another technology could use to reduce the latency thing is the buffering. You might have heard the buffering, where you can buffer the transmission, and you can able to you can be able to make it in the real time using that technology. So for the real time application, the fast speed and the large number of data speed, always choose the Wi-Fi network and Wi-Fi chips based system and Wi-Fi based infrastructure. And for the larger area of coverage and for the lower where you not need that, where the latency didn't matters you, the real time operation didn't matters you, and you have to keep the things sleep for 1 month or 2 months, where you need to transfer the data around a week or around every 20 minutes or 10 minutes, then the LoRa is the good choice. But for the real time application, the Wi-Fi is the best choice.
So how easily can Wi-Fi or LoRa module be integrated into existing hardware design?
In case of the integration of the Wi-Fi and the LoRa modules into the existing hardware design. For example, in case of the Wi-Fi modules, it is easy to integration. Wi-Fi modules are widely available and the can come in the various forms. For example, chip module, SoCs with the well-established interface like UART, SPI, I2TC, etc., etc. And another is the many Wi-Fi modules comes with the built-in TCP RIP stacks with the simplify integration by handling network protocols internally, requiring minimal changes to the existing hardware design. And there are extensive development resources, libraries, and support available, which makes integration easier, especially for the popular microcontroller and the development platforms, for example, ESP32, Raspberry Pi, etc. While we are talking about the power and size consideration in case of the Wi-Fi modules typically require more power, which might necessitate adjustment in the power supply design. The size of the module is adjustment in the hardware layer. On the design, in case of the Wi-Fi mature solutions and the robust support, but carefully consideration with
I think there is some network issue with the Suresh sir because his voice is breaking a lot. So
Why?
actually,
Hello, you can hear me?
Yeah.
yes, but your
Yeah.
voice is breaking.
Now, signal is okay.
Yeah, not sorry.
Should I continue?
Yeah.
Yeah, in case of the LoRa modules for easy of the integration, LoRa modules are also widely available and the designed for the easy integration with the existing hardware through the standard RT RSPI. It is similar to the Wi-Fi. Many LoRa modules comes with the integrated protocol stacks with simply the process by handling the LoRaWAN, WAN protocol and other communication details. LoRa modules often require less power than the Wi-Fi, making them more suitable for the low power application without significant changes to the power design. In case of the antenna and the frequency consideration of the LoRa modules, it is integrating low LoRa may require careful design consideration for the antenna, especially given the different frequencies bands. For example, 868 megahertz to 915 megahertz. The antenna design and the placement can significantly affect the performance. Frequency specific compliances requirement may also necessitate adjustment in the hardware to ensure adherence to the regional regularities. Now, the impact on the design is also very important. LoRa modules are the relatively easy to integrate, especially for the low power application. But antenna design and the frequency compliances must be carefully managed. So, in the brief, both technologies have well-established ecosystem that facilitates integration. But the specific choice will depend on the application's power, size, and the communication need. That's all.
Okay, so what are the PCB design considerations for each technology, like the antenna placement, interference shielding, etc.?
Yeah. So for the PCB design consideration, if you are designing the device based on the LoRa technology or the Wi-Fi, then it is one of the most important factor that you have to consider and you have to look into the while designing. So if you are using the Wi-Fi technology, so Wi-Fi here actually work either between the two frequencies, 2.4 gigahertz or the 5 gigahertz. So it's depend on you. So in case of the Wi-Fi, it's the antenna placement of the PCB should must be away from the actual all the components. It must be towards the edge. And second thing is the orientation of the antenna. So the orientation of the antenna it's one of the important factor that you have to consider because if suppose that you have a device that you have to place it like this. And so if you have the antenna on the top side, if you are design the onboard antenna, so there are two options for the Wi-Fi thing. Either you are using the UFL antenna, the connector that on which most of the chip or most of the board might have seen, or even in the phone you might have seen, or in the laptop might have seen. The antenna is on your on your case, the top case of the laptop or the bottom case of your phone. So actually they are the flexible antenna or antenna that is attached to your case. Or in the laptop, the hinge, the one that you open up, the top part, they have the antenna, that flexible antenna out there after the camera or in the side way of that screen, or many other device. So you can either use the antenna connector to connect the external antenna in the design, or you can either use the PCB antenna. So let's talk about the PCB antenna. You are using the PCB onboard antenna in your device. So if you are then if you are using that thing, then you have to think about the position, how you position your antenna in the PCB, and which direction. So if you're going to deploy the device, stick the device on the surface like this, then the antenna must be on the top so that the waves coming from the antenna, the network is get expanded and diverse in the top side around itself. If you keep the antenna in the bottom side in such case, then if you deploy the device, all the signal is going beyond and it will be absorbed by the bottom surface. And if you're going to stick the device like this on the wall, suppose that you have a sensor node that you have to stick the device on the wall, then your antenna must face towards the exposure of the environment, towards this side. So orientation of the antenna is one of the factors, and then the placement of the antenna. If you place the antenna, this whole antenna in the bottom of the PCB, you have designed the PCB onboard antenna device, and you have placed the antenna in between the PCB. Then the signal coming from that might be affect the whole device, because it might electrostatically charge the rest of the component, and might be interface with the you might face the EMI problem in the device, electromagnetic interfaces, or the signal didn't reach out that well. So in the PCB antenna design, you always need to put the antenna in the side way, in the edges of the PCB. But if you are using the UFL antenna connector, you are going to connect the SMD flexible antenna, or other thing. Then you can plug it and move it in any direction like that. So if you're not sure about like in which direction you're going to deploy the device, then you can use that antenna connector. But for the LoRaWAN technology, the antenna placement is also considerable thing, that you have to put that antenna outside around the edges of the PCB, and away from the rest of the component in the design. And second thing, for the design consideration, you need to think about the electromagnetic shielding, the EMI shielding. So for the Wi-Fi thing, like to comply your device with the regulatory compliances like FCC and C, there are you must have to think about it is not interfacing the other devices around itself, and you have done the proper EMI shielding on the device in case of the Wi-Fi, because the power transmitter is very high. It's around 2.4 gigahertz to 5 gigahertz. But in case of the LoRaWAN technology, it's the the frequency band is around something some megahertz, 680 megahertz, or something like 980 megahertz, around that range. So EMI shielding is not that much necessary in the thing, but but for the Wi-Fi, you have to must think about those things. And second thing is the tracing, the PCB tracing, the line that is going, the track line going on the PCB. So in case of if you are using the Wi-Fi thing, then you have to must trace around the 50 ohm traces, that total impedance on that tracing, that track, it should must be around the 50 ohm of impedance. But while in the LoRa, it's good to have that, but it's not that much of necessary. And second thing is the compliance, like I have already told you, in case of the LoRaWAN technology, a lots of it's differ with the different country. Like Suresh sir have already told you that in the North America they use the different frequency for the LoRaWAN. In the India, that frequency is banned. In the India, whatever the frequency that you are using, in the North America it is banned. So if you have to must think about this, that the frequency, and you must check that frequency, or what frequency you are using using for the LoRaWAN, because if you use the wrong frequency, then it might be hampering the other communication system in your country, and you also might get the legal notice from the government or the army officers, because it is actually interfacing with the other frequency communication that they are using. So in the LoRaWAN case, you have to think about it. But if you use the Wi-Fi thing, then it's a standard. It's either 2.5 gigahertz or the 5 gigahertz, and it is most of the chips that you get in the market might already have the qualified the regulatory like FCC certification and C certification. So these are the things, design consideration on the PCB. You have to think about the antenna placement, and the electromagnetic shielding, and the frequency that you are using.
So, what are the power management strategies required to optimize battery life for devices using Wi-Fi versus LoRa?
Actually, to optimize the battery of the device using Wi-Fi versus LoRa, consider various factors. First, take the Wi-Fi. In case of the Wi-Fi, we have to take adapter power control for adjusting the Wi-Fi transmission power based on the distance, access point, and network condition. This helps reduce power consumption when the strong signal is available. Another is a sleep mode. Utilize the Wi-Fi power supply saving modes such as the power save mode, PSM, and the doge mode to minimize the energy consumption when the device is idle or not actively transmitting the data. In that case, you may use the doge mode. And another is the dub cycling, implementing duty cycle and allowing the device to alternate between active and the sleep states, reducing the amount the time the Wi-Fi radio is the on. Another optimizing point are the efficient data handling. Reduce the frequency and the size of the data transmission by aggregating data and sending it in the larger, less frequency. And another point is optimizing the beacon intervals. Adjust the beacon interval setting to balance between the power saving and the network performance. Now come on the LoRa. For LoRa, also you have to take adaptive data rate. Use LoRa adaptive data rate ADR to dynamically adjust the data rate and the transmission power based on the network condition, optimizing the battery life while maintaining communication efficiency. Another is a low duty cycle. LoRa is designed to operate with the low duty cycle, which helps conserve battery life, ensure your device adheres to these duty cycles limitations to prevent the excessive power consumption. Another is the deep sleep mode. It utilizes LoRa deep sleep mode to minimize power consumption during the idle period. The device should wake up only when the necessary to transmit the data and the receive the data. And efficient payload is also playing an important role to save the power. Minimize the payload size and transmission frequency to reduce the power users. Only send essential data and use the efficient data encoding scheme. Another is the adaptive transmission power. It adjusts the transmission power based on the communication, distance, and the required signal strength to save the energy. By implementing the parameters which explained to you, these strategies, you can effectively manage the battery life for the device using either in Wi-Fi or in case of the LoRa. That's all.
Okay, so um, how does the operating frequency of each technology impact the design of RF front-end, including filters and amplifiers?
Yeah. So for the Wi-Fi network, as I've already told you that it works in the 2.4 gigahertz or the 5 gigahertz. So it might need the band pass filter that is necessary to filter out the unwanted signal other than those frequency range. And in case of the high frequency, the filter size or design can be the smaller it is bit more complex than the other one. Then you might also need the amplifiers like low noise amplifiers and the power amplifiers to amplify the signal received by the antenna and minimize the noises as well. So the one is the band pass filter, another is the low noise amplifiers, another is the power amplifier that also might need and generally needed in the 5 gigahertz in case of the Wi-Fi. And if you look at the LoRa band technology, then it's the sub gigahertz band technology. Sub gigahertz band means it's some in some region it's working 433 megahertz. Some region it works at 868 megahertz. In some region it works at 15 megahertz. In the North America, it's work in 915 megahertz, while in European, it's used 433 around or 868 megahertz. So it's the some megahertz band. So in this band, you also need the band pass filters. So filter out more lower frequency than the one you are using, and the size complexity is little bit not that much complex in compared to the Wi-Fi, but the design is simple and size is bit larger than what you used in amplify used in the Wi-Fi things. And next is the amplifier. Then like in the Wi-Fi thing, here you also need the low noise amplifiers and the power amplifiers to amplify the big signal and give you the and also reduce the noise as well.
Okay, so I think my last question now. So how complex is firmware development for implementing Wi-Fi or LoRa communication protocol?
Of firmware development to the implementing Wi-Fi or LoRa communication protocols varies in the complexity depending on the several factors. First, consider the Wi-Fi. The first factor which we consider is protocol complexity. In case of the Wi-Fi communication, it involves complex protocol including TCP, IP, stack, security, WPA or WPA2, etc., and advanced features like quality of the service QoS. Implementing these features required through the understanding and integration of the various network protocols. Another considering point is the driver and the stack integration. For where most integrate and the Wi-Fi drivers and the stack which can be complex due to the need of the handling various states such as the scanning, connecting, and the maintaining the connections. Another is the security. Implementing Wi-Fi security protocols such as WPA2 or WABA3 involves handling ecosystem encryption and the authentication mechanism, which can be complex and require adherence to the security standards. Another is the power management. Efficient power management in the Wi-Fi require handling power saving modes, which adds to the complexity of the firmware. Another is network handling. Firmware mutually handle various network configuration, dynamic changes, and the potential issues like the interference and the network. Now, come on the firmware development for the LoRa. In this case, also protocol simplicity. LoRa communication protocol are generally simple compared to the Wi-Fi. It is focusing on the long range, low power consumption with the basic packet structure and the acknowledgement of the mechanism. Another, the low power communication. LoRa in firmware often involves managing low power communication, right? Another is adaptive data rate. Implementing LoRa adaptive data rate ADR requires managing data rate adjustment based on the network condition, which adds some complexity. Another thing, low power management. LoRa is designed for the low power operation. So firmware must efficient handle deep sleep mode and the minimal wake-up period, requiring careful design to power efficiency. And the last one is the network configuration. For LoRa, network LoRaWAN, long range wide area network, implementation, managing network configuration. such as joining network and the handling the data transfer in a public or the private network can add the complexity. Overall, while Wi-Fi firmware development can be more complex due to its sophisticated protocol and the integration requirement. So LoRa firmware is simple but still require careful handling of the low power and the low level communication aspects. So these are the few specific complexity and also depends on the device requirement such as the need of the custom features or the integration with the other system. That's all.
Okay, so this brings us to the end of this live discussion. I hope the discussion was very useful for you people. If you have any question, you can post your questions in the comment section. We will get back to you all in the next session. So thank you, Ashwini ji and Suresh ji, for your time.
Thank you. Thank you.
Thank you.